Okay, let's talk about food noise. You know that constant chatter in your head about food? The one that's always dictating what you eat, when you eat? It's exhausting, right? Well, a whole new class of weight loss drugs seems to be doing the impossible. They're just silencing it. The results are stunning. But the big question has always been, how? I mean, how does a drug actually get inside our brains and just flip a switch on cravings? For the longest time, it was a total mystery. But that's all starting to change. So, what exactly is food noise? Well, scientists have a more formal term for it, food preoccupation. And it's so much more than just feeling hungry. It's this persistent, kind of distressing focus on food that can literally hijack your thoughts. It can lead to what's called loss of control eating, that feeling where you just have to eat, even if you're not physically hungry. The best analogy I've heard is it's like having a radio stuck on full blast in your brain, and it's playing a food channel you just can't turn off. And this is where these new drugs, these incretin-based therapies like Tirzepatide, enter the picture. Yeah, they're incredibly effective for weight loss. We all know that. But people taking them report this profound psychological shift. The food noise, it just stops. That internal radio goes completely quiet. It's a game changer. But for all their success, there's been this one massive nagging question, which is, how do they actually do that? How do they work inside the brain? For so long, it's all been theory, educated guesses. But now, and this is so cool, for the very first time, a completely serendipitous case study has given scientists a direct window, a real-time look inside the brain to finally see what's going on. All right, so to crack this mystery, researchers needed to get inside. They had to essentially eavesdrop on the brain's private conversations, specifically in the command center for reward and motivation. You know, the part of the brain that's driving all our cravings. And their target was a very specific spot deep in the brain called the Nucleus Accumbens. You can just call it the NAC. Think of it as the brain's absolute hotspot for cravings. It's a huge player in our reward system, and this is the key part, it's just packed with the exact receptors these new weight loss drugs are designed to interact with. So yeah, it was basically suspect number one. So how do you listen in on something like that? Well, they used this pretty groundbreaking tech called a brain-responsive neurostimulation system. And this involves an incredibly rare, super complex surgery. We're talking about implanting tiny, flexible electrodes directly into the nucleus accumbens. This gave them an unprecedented direct line into the brain's craving center. It's pretty wild stuff. And you can really think of these electrodes as tiny, tiny microphones for the brain. But instead of sound, they're picking up on the electrical signals, the brainwaves. These are the real-time conversations happening between neurons. And for the researchers, this meant they could finally eavesdrop on that internal chatter with a clarity that's just never been possible before. Okay, so they're listening in. What did they find? They discovered something absolutely incredible, a distinct measurable brainwave, a specific signature that was, without a doubt, the sound of food noise itself. What they found was this specific low-frequency brainwave. It's in what's called the delta-theta band. Now, all you need to know is that these are some of the slower brainwaves that are tied to things like motivation and emotion. And here's the kicker. When a person was experiencing that intense food preoccupation, this exact signal got stronger. It got louder. So for the very first time, food noise wasn't just this vague feeling someone describes. It was a physical, measurable thing, a biomarker. And this is where the whole thing goes from a cool lab finding to a really compelling human story. Because this discovery was confirmed in the most amazing way you can imagine, through the real-world experience of one single patient. So, meet participant 3. Her unique situation was basically a perfect storm for scientific discovery. She had these brain electrodes implanted for a different study on loss of control eating, but at the same time, she was already taking Tirzepatide for her type 2 diabetes. This was the golden opportunity. Researchers could see in real time what her brain looked like while the drug was supposed to be working. And this timeline really lays it all out. Check it out. For the first few months after the surgery, things are good. It's what they called a quiescent period. Her Tirzepatide is working, she's reporting very few food issues, everything's quiet. But then, you get to month 5, and bam, the researchers see it in the data first, that food noise brainwave just appears. And sure enough, right after that, her own reports confirmed it. The food noise was back. I mean, this is the whole ballgame right here. It's this direct one-to-one link. When the drug was working and her food noise was quiet, that brain signal was gone. It was absent. But the moment she started having those breakthrough episodes, when the drug's effects started to fade, The biomarker was right there, loud and clear. You just can't ask for more perfect correlation. And you can see it in her own self-reported experiences too. The number of these severe episodes just shot up later in the study. But what's so important is the timing. The biomarker showed up in her grand scans first, and then her experiences and behavior followed suit. The brain signal was like a warning shot.
Okay, but this is the money shot. This is the visual proof. On the left, that's her brain during the quiet period. See all the cool blues and greens? Low activity. Now look at the right. That's the loud period. See that bright yellow flare lighting up? That's it. That is the food noise biomarker, caught on camera for the first time ever, right as the drug's effects started to wear off. Incredible.
So this is obviously way more than just a cool picture from a brain scan, right? Discovering this one signal could open up a whole new world for how we understand and treat not just obesity, but maybe a whole range of complex brain disorders.
So what this gives us is something scientists call a target engagement biomarker. It's a fancy term, but the idea is actually pretty simple. It's an objective biological signal that proves a treatment is actually hitting its target in the brain. In other words, we don't have to just rely on asking a patient, so how are you feeling? We can literally look at their brain activity and see for ourselves if the drug is doing what it's supposed to do.
And the researchers who published this in Nature Medicine really said it best. They wrote, the biomarker is present when severe food preoccupation occurs more frequently and is absent when it occurs less frequently. It's just that simple. The brainwave perfectly mirrors the person's real-life experience. It's that direct link between what's happening in the brain and what we actually feel. But here's maybe the most mind-blowing detail of all. The biomarker didn't just show up at the same time as the food noise came back. It actually appeared in her brain scans about 7 weeks before she started reporting the worst of her symptoms. Think about that for a second. It means this signal isn't just a symptom, it's a predictive signal. It's like an early warning system built into the brain. And that opens up some really incredible possibilities for the future. I mean, just imagine a system that could warn you weeks ahead of time that your symptoms might be coming back. Imagine doctors being able to personalize your medication dose and timing based on your actual real-time brain activity, not just some standard protocol. Now, obviously, this initial study was super invasive, but it's a crucial first step. The goal is to figure out how to monitor the same signal in non-invasive ways, maybe with something as simple as a special cap. So it really leaves us with this huge, powerful question, doesn't it? Could listening directly to our brains completely revolutionize how we treat not just obesity, but all kinds of complex disorders? This one patient, this one study, has really kicked open the door to a future of truly personalized, brain-based medicine. A future where we stop just reacting to symptoms and start listening to what the brain is telling us, maybe even before we're consciously aware of it ourselves. And a shift like that, well, that could honestly change everything.